Read the question. Some simple earlier what happened, the mass ejected. No, now I'm just bringing a situation where the mass will be ejected perpendicular to direction of motion. We took all the cases along or opposite to motion. No, read the question. Try to don't draw a spaceship, just at least show some block, something, and mass ejected. Okay, I'll proceed like this. A spaceship of speed we know traveling along suddenly shorts out 1/4 of its mass. So let's take the mass of system Bm. It is moving with a speed 2v0 along positive x-axis. 1/4 of its mass, or make problem simple, 4m you make it. It will eject how much? 1/4 of mass. How much will become 3m?
Positive y-axis.
Spaceship of speed v0.
So it should go upward.
Okay, that one here. Part with speed 2v0 okay, not needed again. Let it be. And what do you expect this? How it should move? So let it acquire velocity vy and let this be vx. Now, what is this ejection? The internal force, no? So again, the net force on the system along x-axis 0, along y-axis also 0. The net force on system along x, along y, because what all that ejection occurs due to internal force, and due to internal forces momentum will be conserved. So therefore, initial momentum equal to final initial momentum along x-axis 0. Finally, what happened? M 2v0 minus 3m vx. So vx is equal to how much? 2v0 by 3. The net force on system along y-axis should be 0. So initial momentum equal to final momentum. Initial momentum along y-axis 4m v0. Finally 3m vy. So what is vy equal to? 4v0 by 3. There's a remaining part, no? And this is spaceship. Now he's asking what can this speed? So this, what is v? We can write it as vx square plus vy square. 4v0 square by 9, 16 v0 square by 9. So this will be the speed of the remaining part. Okay, now I want to change the direction of motion. So what I should do? See, earlier how it was moving? It was moving along y-axis. Now if mass is ejected along x-axis, what will happen? Yes, I can change the direction. No? So how to change the direction of spaceship? By ejecting a mass. Of course, the speed of the spaceship will change. But here priority what happened? The priority is given to change the direction. Sir, I'll increase the speed. I'll increase from from 2v0, I'll make it v0. Tell me anything will happen to this theta? Yes, theta will change. So by ejecting some amount of mass and also by controlling the ejection speed, we can control this theta. Okay, this one, this angle theta depends on what? What amount of mass ejected and with what speed ejected. So you do get very good questions based on this. Be careful. Okay, now I'm coming out of this overall picture. Now we'll explore conservation of linear momentum related to different situations, different systems. There it was only about the system mass ejected, mass gained. Last one more is there. If a trolley is moving with a speed v naught, and a person, what happen with a parachute? He will slowly land onto the moving trolley. Now, what will happen to the mass of the what will happen to the speed of the trolley? It will just slowly land. The person or the parachutist lands slowly on the trolley. He will not having any velocity along x-axis. Then the person along with the trolley the trolley, this thing, he will land and come to rest. So he'll move together with the trolley. Now, what are the situations we can bring it here? What are situations we can? Initial momentum, again, momentum is concerned. Initial momentum, m1 v naught, final momentum, m1 plus m2 into v. So what happened? The momentum of system, in fact, decreased, no? Also, like the speed of the trolley, in fact, decreased. So if a body is moving and if it gains mass, if the system gains mass, what happened to speed of the system? Will decrease.